You know, I did this with my way of doing things, but you could equally well have solved this problem with Taylor's theorem, right? If you don't like my way of my algebraic chicanery, Taylor's theorem would have been a perfectly good way to solve this problem. It wouldn't be that hard, you know? We've got f of x equals to what? X e to the 3x, yeah? So what's f prime of x? Right? What's f prime prime of x? Well, it's 3. If you guys took 3 minutes of your time to do it carefully, you'd get this, right? My time is limited in here. But it should be quite apparent that f of 1 is what? Yeah. What's f prime of 1? 4e cubed. What's f prime prime of 1? 4 times 3 is 12. 12 plus 3, 15. What's Taylor's theorem centered at 1 say? It says f of x is equal to f of 1 plus f prime of 1 times x minus 1 plus 1/2 f prime prime of 1 times x minus 1 squared, right? This you should know. This is kind of important. I mean, it's not kind of important, it's important. It's one of the, top 3 theorems we've talked about this semester, for sure. And so what is that here? That's e cubed plus 4e cubed times x minus 1, right? Plus 15 over 2 e cubed times x minus 1 squared plus ... And there it is. Now, the reason I solved it the way I solved it is because I sometimes don't feel like differentiating. I'd rather just do algebra, But I hope we got the same answer. E cubed, 4e cubed, 15 halves e cubed, yeah. Right. Now, my way of doing things becomes better there are other problems where differentiating as many times as you need could get very tedious, and the way I'm doing it here would be a better way. So I'm not saying that my tool is not a good way. I'm just saying it's not necessary for this problem. What was this? This was a binomial series problem, but you had to factor the 3 out. You factor 3 out, you get 3 to the minus 2/3, 1 plus u to the minus 2/3. Binomial series gives you that, and so there it is. This one, just straight multiplication. Collect terms order by order. This one is a division of series problem. All right. I think you guys actually did pretty good on D and E here, but you guys had some trouble on B and A, if I remember right. But I think everybody ought to be able to get A and B here if I ask them again. I hope that it's not still seeming like dark magic to you. If it is, I'm sorry. Integrate x to the 7th times x cubed. A lot of you missed this. That is unfortunate, because this is not an unfriendly question. What this is designed to get you to do is to use the power series for sine with the substitution x cubed, right? Now that gives me 6n plus 3. I actually multiplied the x to the 17th in this time. I got my 20. I seemed to have trouble doing that earlier in test. And what do we got? We got that, and then we just integrate term by term. So I pick up a 6n plus 21 and x to the 6n plus 21 plus and there you go. Yes?
On my test, I wrote that it was from n equals 0 to infinity, and you crossed it out and said it should be n equals 1.
I'd have to look at your test to tell you why I did that. Now here, this was just straight, find the 3rd order Taylor polynomial. And admittedly, the differentiation here was a bit of a drag. I think this was a homework problem for you, which is why I put it in here. Because I promised I would put a certain number of homework problems in the test. And sometimes that worked against me because I actually did, and it's a bad problem, and I think this is an example of that. But anyway. The problem 11 was essentially a bonus question. I wanted to see if you guys could think through it. But here's the idea. As x goes to infinity, I definitely have x as positive in that limit, so I can factor x squared out. I got 1 plus 1 over x. But you see, as x goes to infinity, 1 over x becomes very, very small, which means binomial series is a reasonable tool to use here, because 1 over x is a very small term. So even if I keep the first two terms in the binomial series, I'm doing well in the approximation. So that's x times 1 plus 1 over x to the 1/2, which is this. And so I replace that with that approximation. The x's cancel. I'm just left with a half plus stuff that has 1 over x type terms in it. So this piece dies as x goes to infinity. I'm just left with a half. This is an example of what's called an asymptotic argument. Now, of course, the other way to do this would be what? You do some sort of like rationalization argument, multiply by a root plus root, or something like that. Look at that as the square root of x squared minus the square root of x squared, and then you could do the algebra. But I think this is considerably easier than going down that algebraic path. Again, alternating series estimation theorem is the hero here. And I worked a lot of these in class, right? I can't remember how many times I said at the end of a problem, all right, let's calculate the 50th derivative, right? So this is that problem. Anyway, I will shut up. You guys have any questions? Did I already talk about test 4? It's too fresh. Talk about test 4.
How much will you emphasize the concepts on test 4?
I forgot. What's on test 4? Well, I would certainly hope if I put problem 1 or 2 or something like it on the final, you guys could do those. Definitely you guys need to work on how to parameterize hyperbolas and circles, some of you. I'm not sure that that's actually the case. I say that, but again, this problem here, this problem showed me that you haven't, it's hard for me to judge. Maybe you have a knowledge, but you just don't trust yourself. You know that on the quiz I had an ellipse, so surely there must be an ellipse on the test. This thinking is always incorrect with me. This is not how I function. I ask myself the question, what's a similar question that sees if they have rounded out their conceptual understanding of that part of the course. So in fact, the fact that I put an ellipse on the quiz, you would almost expect me to put a hyperbola on the test if you know me. But that's not guaranteed. Wait a minute. So if there's an ellipse on the hyperbola. Yeah, it must be a parabola on the final then. No, that's unlikely though. Because what you don't know is I don't like parabolas. So there's that. But so guys, I mentioned, I think we did talk about this actually, but this thing right here, I think a lot of you know how to do that, but you just didn't. At this point, by the time you got to this part of the problem, you were so sick of all this that the thought of doing this as well was not really on the table, right? It was just the graphing alone was kind of too annoying. So the fact that I've also asked this pesky other question here was kind of missed. But yes, of course you should review all these things. And can you find the tangent line to a path, parametric curve? Can you find, is it concave up or concave down? I think arc length is a pretty important idea there. Yeah. So there are some, I mean, I will tell, just like the test, I would not put a centroid on the final because we didn't have that on the test this semester. I didn't emphasize it in the homework. So center of mass or centroid, that's not something I really emphasized. So if there was an application, if you think about it, what is it? What are the applications we've done of integration this semester? Arc length, probability distribution, surface area, right? Volumes of revolution. See, what else do we do in here? I mentioned arc length, surface area, right, of a surface of revolution. It would be kind of surprising if I didn't have a plot polar curve problem, wouldn't it? But then again, I want the final not to be too long, so something's got to give. I just don't know what's going to give yet. I'll probably make a final which is too long and then randomly remove problems from it. So that's the other reason I won't forecast what percentage is from which test. I will just tell you that there will be integration. There will be a lot of integration. Did I mention there'll be integration? There'll be integration, yes. So integration is important. Yes, it will take you 2 hours, I think. Yeah, yeah. There is no extra time. The tests are timed. But I do think finishing in 2 hours will be possible. It depends on whether you work. If you work fast, maybe you'd be able to finish in an hour and a half, you know? Then that'll eat the half hour. The mistakes will eat the half hour, won't they? That's what they do. I know, because I do that too. All right. Well, it's been fun, you guys. I have not. Oh, I should have left that open. I have not studied my Calc 3 roster. Are any of you in there? Josh, Grant. I'll remember your name next semester, I promise. And John. Yes. Sorry, Grant. There's no excuse. Shame on me. All right. Because I didn't remember Grant's name, I'm going to dedicate a problem on the final to Grant, and you guys will like it. It'll be a memorable question. You'll like it. It's not. Sometimes I make a question, nominated to a student, and it's a bad thing. But no, this will be a good thing. Everyone will like this problem. All right. When are we having the final? 3:30 on Friday. 3:30 Friday. Is that this Friday? Yep. Dang. I better go write that final. Here. Let me turn off. There's a very important thing to do. At the end of class, when you're your own cameraman, you have to turn off the camera. Otherwise, you'll put a half hour of static on your tape.